The producers and distributors of Tech AV training material welcome you to the first module in a series entitled Programmable Logic Controllers. The overall objective of this series is to explain the working principles of modern-day PLCs, how they are programmed, and how they fit into automatic control systems. In this module, we shall be overviewing the fundamentals of automation control systems, which will lead you to a working understanding of basic automatic control methods using logic devices. You will find that your workbook has been designed to fulfill an integral part of this training process, so ensure that you have read the resource notes before viewing each section of the program. Virtually all high-volume and continuous production operations have, at least to some extent, the need for an automatic system of monitoring and controlling the many variables that constitute a process. For this reason, it is most important that operators, artisans, technicians, and engineers have at least a working knowledge and understanding of how such systems operate in order to keep the production process operating at optimum conditions. No matter how complex an operation or how complicated the process may be, the whole system can be kept under rigid control and standards or qualities met consistently, thanks to the power of modern-day electronics and particularly the highly popular Programmable Logic Controller, or PLC, as it is often called. It is the intention of this series of programs to help you to fully understand the operating principles of typical PLC-controlled systems, including the various devices associated with PLC-managed systems in the events that constitute a typical process. So, like any other apparently complicated-looking operation, let us start at the beginning. Back to basics, which will form the foundation of our understanding. In this very simplistic example, imagine that the operator's job is to sort various blocks according to height, namely those that are 85 millimeters long or longer, and those that are shorter than 85 millimeters. Before the advance of progress in industry, the obvious method would have been to physically measure or gauge the size of each block in order to decide which group it belonged to. Performed manually, the job is tedious and time-consuming. So, how could we make the process faster and easier? Well, let's analyze what the operator is doing. First of all, he is gathering information. He needs to know how long each block is before he can know where to place it. We call this input, and from this input he makes a decision. Then he asks a simple question. Is the length of this block greater or equal to 85 millimeters? Yes or no? And based on the answer to that question, he decides where to place the block. After making a decision, he goes into action and places the block in its proper group. In essence, then, any automatic control process consists of these three basic but important steps: gathering information, making a decision, and then taking action. In a typical automatic control system, sensing devices bring input to a logic system that consists of circuits that are programmed or arranged to activate or deactivate working devices in the output section. Based on the state of the input devices, the logic decides which of the working devices should be operating at any given time. It follows that input, logic, and output sections will make up the fundamental structure of any control system, and that no matter how complicated the processes are, the system can be designed and understood by simple yes-no decisions. Now, applying these fundamentals, A very simple machine could be constructed in order to make the block sorting task a lot easier. Basically, a traveling belt and a mechanical height gauge. By setting the bar to exactly 85 millimeters above the belt and then hand cranking the drive system, any block that is greater or equal to this size will be pushed over by the bar, and the operator simply removes the block and places it in its own pile. Shorter blocks, however, will be unaffected by the bar and pass through to be placed in their own pile. Although this system is crude and manually operated, we are in effect moving toward a more efficient automated system. What we have created is a machine that essentially makes decisions. The bar asks the same question over and over again. Is the block 85 millimeters long or longer? And it gives a simple yes or no answer by either knocking over the block or allowing it to pass underneath. The operator then gets a clear input message that helps simplify the sorting process. This basic yes-no logic is the key operating principle of any programmable logic controller. Keep this yes-no principle in mind as we move further into the program, and you will have very little trouble in understanding the way in which the PLC manages a system. Now we're going to make the sorting job a little more sophisticated by introducing some basic automation ideas. We not only want to separate the long blocks from the short ones, but the requirement is to count 10 short blocks, then sound the alarm and stop the conveyor. To control these operations, we're going to use electrical relays that we shall be discussing after the break.